right, guys. Let's talk about graphs of quadratic functions. Want to? Yeah, sounds good. Let's do it. All right, so what we're going to look at today is we're going to look at basically any quadratic function, right? So any quadratic function, can be written in the form ax squared plus bx plus c. And what we want to talk about is, what do the graphs of these look like? Is there something similar about these graphs, just if a, b, and c are different? What do they look like? Have we seen graphs that look like quadratic functions before? So let's consider the graph of some function f of x, and we'll let this be 3 times the quantity x plus 1 squared minus 4. All right, so we know some stuff about this, right? We know this from 2.5. So some of the stuff we know about this is that this 3 right here means it's been stretched, right? A vertical stretch. This plus 1 means this guy has been moved to the left 1 unit, and this down 4 means, or minus 4, means that my function has been shifted down 4. And we know that this is the graph of a parabola. So let's see if I can do something here. So maybe not. I was gonna see if I could get this to draw my lines for me, but apparently that's not going to happen. So I'm just going to draw them by hand. So what do I know? Again, this has been shifted down 4 to the left 1, right? And then it's been stretched by a factor of 3. You know, I could see if I put in 0, I would get 3 times 1 minus 4, which is -1. So I know I'm at -1. And then this guy has some symmetry. So it goes little something like that, okay? So that if I have it in this form, so if I have something in this form, I can draw the graph of this function. And some interesting things about this function: has a minimum value, if you notice. So minimum is the smallest y value that it attains. What is my minimum value? My minimum value is -4. It occurs when x is -1, right? And I know it opens up because this 3 is positive. So there's a lot of things I know about this function if I can get it into this beautiful form right here, this 3 times x plus 1 quantity squared minus 4. Notice though, if I multiplied this out, if I took that x plus 1 times x plus 1, subtracted 4, 3, I'm going to FOIL this sucker out because all of you know that you do not FOIL or distribute the squared. You know that. And then I'm going to simplify this a little bit. I'm going to go ahead and, put some stuff together. 3 minus 4 is -1. So look at that, you guys. So really, what I've shown, this form right here is the same as this quadratic function form up here. So what we are going to try and do is we're going to try and work with this form right here and work to get it back into this form that we started with. If I can get my quadratic function into this form that I started with right here, which we're going to call standard form. If I can get it into this form, there's a lot of things I can do. I know that I can graph it, right? I know what it looks like. I know if it's going to have a maximum or a minimum value. And if I get it into that form, I'm going to be able to determine what that maximum or minimum value is fairly easily. So that is going to be our goal today. So our goal today is to get these functions, quadratic functions, into what we call standard form. So let's write that down, and then we're just going to do a bunch of examples, and then we're going to do some application problems, also lovingly referred to as word problems. So here's what our standard form is going to look like. It is going to be a times x minus h quantity squared plus k. Notice it's kind of the same as this. We just want to put in variables. The reason we want to put in those variables a, h, and k is because that's going to, do those transformations to my function. And so if you have something like this, we know a couple of things. If a is greater than 0, okay, this is just that number out front, like in this case I have 3, then we know it's a parabola. I don't know if I mentioned that look at all of these quadratics right here are going to look like x squared just shifted around some, because we can take any quadratic function like this and we can actually get it into the standard form, which means I just have a quadratic, or excuse me, I just have x squared shifted around. So this is a parabola opening up, right? And because of that, it's going to have, if it's opening up, I'm making little like U's with my fingers here that you can't see. Opening up, we're going to have a minimum. And where is that what is that minimum going to be? We're going to have a minimum of k, and where does it occur? At x equals h. Because look at this, my minimum value, right? Look at this k right here. So this 4 and that -4 correspond to each other. That's going to be my shift up and down, right? And so that's going to be my shift in my y values. So that's why that will tell me if I have a minimum. And then where does it occur? At my corresponding x value, which is this shift left and right. So again, look at here, my minimum is -4 because that's how much my parabola was shifted down. Where does it occur? At -1, because that's the direction my parabola was shifted in the x direction. So this point right here is what we call the vertex. We'll write that down here in a second. And the vertex is always the point where my parabola attains its maximum or its minimum value. If a is less than 0, we have a parabola opening down, because we know if a is less than 0, that means it's negative. Okay, opening down. So if this guy was a -3, then I just know I would have, let me grab a different color here. My parabola just would have done this, right? If it was a -3, and now instead of saying it's a minimum of -4 at -1, I would say in this case that it's a max of -4 at x equals -1. Again, this is if I had a -3 as my a value there. So again, let's write that down. We have a parabola opening down, and if it's opening down, we have a maximum of k at x equals h. All right. Another thing, that point, if you get it into standard form, then the vertex is h comma k. So that's what we're going to call the vertex there. It's that point where the parabola basically changes from decreasing to increasing, or increasing to decreasing, either one. It's where my maximum and my minimum occur. It's that like the bottom of the bowl there, or the top of the bowl if your bowl's upside down. That's what we're going to call our vertex. Again, that makes sense that this h is positive, because in the standard form it has a minus sign. And that means I would be moving to, if h is positive, then I'm moving to the right h units. Now, again, look, if h is negative, right, then this would become a positive, and that tells me I'm moving to the left. So we can find our max, we can find our minimums, we can find the vertex, and then the other thing that we can also find is something that we call the axis of symmetry. And the axis of symmetry is just going to be the line x equals h. So let me tell you a little something about the axis of symmetry. Let's see, I need a different color here. Axis of symmetry is going to be the line. If I put a line here, if I drew this red line, well, I am drawing this red line, making it, ooh, that's a pretty good line, you guys. And it's a dotted line too. That was freehand. All right, so if I put in this dotted red line, why we call this the axis of symmetry is because this parabola right here, it has symmetry about that axis. So we talked about symmetry a little bit. Our symmetry, right, is if I could fold my computer, I'm not going to try, over on that red line right there, then this parabola would match up, okay? And why is it x equals h? Because remember, x equals a number is a vertical line. And why is it equal to h? Well, oh, I didn't want to put h right there. I wanted to put what actually is h in this case. In this case, h is -1. It's just the x value that my vertex goes through. So you're going to want to make sure you put, when I ask you what is the axis of symmetry, you're not going to put it's -1. That doesn't make sense. The axis of symmetry is a line, and you need to write it as the equation of a vertical line, which is x equals blah. Okay. We need to do some examples of this stuff. So let's do that. We'll do what I want because I'm the one that's making this video and you hopefully are watching it. So let's, for all of these, determine the max or min and where it occurs. The vertex and the axis of symmetry. So for all of these. Now, listen, I want to see you guys using completing the square to do this. I know if you read in your book or if you remember from like your high school math class, they're like, well, your vertex is x and b negative b over 2a or something like that. I don't even remember. If you don't have to, we shouldn't have to memorize formulas. We should be able to use reasoning. That's what math should teach you, right? Is reasoning skills. We should be able to reason through what the vertex is by putting it into standard form and knowing what the transformations to x squared do. And then that gives us our vertex. So I will be putting that on the test next week. I will say, use the completing the square to determine the following. So you need to make sure you're using completing the square and you're not using these formulas that we don't know about. So this completing the square is going to be a kind of interesting because we're going to have to do this a little bit differently than we did when we used completing the square to solve equations, okay? Because we're going to have to mess with this a little bit, but we're not scared. We can mess with things. All right, so I need to get this into standard form. So just like when we use completing the square to solve equations, I want to have a 1 in front of the x squared term, which I have. And now we're going to do kind of the same process that we did before. I'm going to take half of -6, which is -3, and I'm going to square that and put it in here. So if I take half of -3, square it, I get +9. And so because I've brought in that perfect square, this part right here of my function is going to be a perfect square. And so everything in the yellow there, I will be able to write as a perfect square. This is going to contribute to whatever my k is going to be. But you might be like, Sarah, but you brought in a 9. Look at this function is totally different now. If I actually simplified this whole function right here, I would get x squared minus 6x plus 10. That is not the function I started out with. So that is not right. Like they're not going to have the same max and mins and everything. So here's what we need to do. I brought in a +9. I need to take it away. All right, I have to make this equation balance. I have to make sure that what I actually just brought in was 0. If you simplify all of this, you would get 9 minus 9, which is 0. So you actually didn't change the function at all. It looks different because you have this +9 and this -9. But if you actually simplified it, if I brought in 9, I have to take away 9. I have to make that balance. Okay, I hope that makes sense. So what do we get here? Everything in the yellow then, remember that factors into x minus 3 quantity squared. And then I get, 1 minus 9, which is a -8. So do you see then how I use that +9 to get a perfect square? Then I took the 9 away, and that helps me see what my vertex and my k is going to be. Whenever I do these, I always make a little sketch. It doesn't have to be perfect. I know this is going to be shifted to the right 3 and up 8. So I'm going to make, down 8, excuse me. That's a negative. Down 8. And what do I know about this? It's opening up because I have a positive number in front here, so it has not been reflected about the x-axis. And when I do these, I don't like graph that perfectly. On your homework, they're going to have you graph them. You can always graph them perfectly by just plugging in some values, right? I know it's shifted over 3, so I would maybe, look at, okay, well, what if x is 4? What if x is 2? Numbers around 3 to get those other 2 points that I need. But mainly when I just graph it, I graph it so I can see what's happening. Because now when I look at this, I can see right away that I have a minimum. So what is my minimum? I have a minimum of, what is my minimum? Well, my vertex is 3, -8. My minimum is always, what is my minimum function value? What is my minimum y value at x equals 3? So there's my minimum. My vertex, that's pretty easy to do. My vertex is just 3, -8, that's a point. And my axis of symmetry, or AOS on the math street. I don't know what the math street is, but it's a pretty cool street. I am at a math conference right now, so I bet I could go and find it. All right, so those are the things I needed to know. I needed to know my vertex, my axis of symmetry, and my minimum of -8. Okay, so I hope that makes sense. This part right here, you know, that's going to be the hardest part. I want to show you another example where, so this is the same stuff, find the max and min, vertex, all that good stuff. I want to show you another example of where maybe I don't have a 1 in front of, let's say I have a 2 in front. I'm sorry, they're doing something outside my hotel room right here. I'm not exactly sure what it is. Let's do 2x squared minus, we already did a minus. Let's do plus 20x minus 7, something like that. Okay, 2x squared plus 20x minus 7. So, whoa, keep doing that. So we know that I must have a 1 in front of my x squared term to be able to complete the square. I'm actually gonna give myself a little bit more room there. All right, so what I'm going to do, when you want to get a 1 in front of that x squared term, I'm gonna take a 2 only from the terms that have x's in them. Excuse me, because to complete the square, I don't care about the -7. Sorry, -7. I think you're a lovely number, but for right now, you're of no use to me because you're not going to help me complete the square. What is going to help me complete the square is this middle term right here. So I'm going to take a 2 out. I factor a 2 only from the first 2 terms. Okay, so I bring this 2 out. Now I'm ready to complete the square. Now this is going to kind of be a little crazy. It's going to be crazy, guys. It's cray-cray. Some of my students told me you guys don't say cray-cray anymore, which makes me sad. I think that's a great word to say. So look at what I am bringing in. I am bringing in 25, okay? So I don't like that too. I'm going to bring in 25 to complete the square. Now, here's where we gotta be careful, because a lot of you will just be like, all right, I'm gonna take 25 away. I brought 25 in, I'm gonna take 25 away. No, you're not, because you didn't actually bring in 25. Look at this 2. If I were to FOIL this out, this 2 is going to go through to every single term here. So you didn't bring in 25. You actually brought in 2 times 25, which is 50, because this 25 is in these parentheses right here. So instead of taking out 25, I'm actually going to take out 50. I hope that makes sense. Again, I brought in that 25. I want everything inside these parentheses to become a perfect square. This 25 is being multiplied by the 2. That means I'm not going to be done. We'll keep on. So because that thing is being multiplied by the 2, then I know that 25 times 2 is 50. So I actually brought in 50. So I have to take that 50 away. Here is what I strongly recommend you do. You need to FOIL this all out and simplify to check your work. Okay, you need to FOIL all of this out. Whoops, why am I not right? There we go. I want you to FOIL all this out and simplify. If you did it correctly, this whole thing right here, what is going on with my pen, had better equal that function that you started with, especially on the test. FOIL that out. Make sure that it's exactly, do it on the side work, do a little bit of side work. FOIL it out, simplify, combine like terms, make sure that everything is the same, okay? All right, so now I'm not gonna do that, you can do that. All right, so now what I wanna do, my colors are getting a little crazy here, but I want to rewrite this stuff that's in the red box as a perfect square. So I still have the 2, okay? I'm gonna make that x plus 5 quantity squared. Remember, it's always whatever number here that we squared. And then what do I have? Minus 57. Now that I have that, I know that this guy has been shifted to the left 2 and down 57, wherever that is. And it's a parabola opening up, stretched by 2, right? But opening up. And so I can say, all right, we have a min of negative 57 at x equals negative 5. My vertex, okay, is -5, 57. And what else? My axis of symmetry, or my AOS, is x equals -5. Okay, I hope that makes sense. What? I say that like you've done something wrong. I'm a mom. I'm used to having that tone of voice. But I do hope that makes sense. Let's look at another one. Let's look at one maybe with some fractions, because you knew that was coming. You knew it. You knew it. All right, let's do another example. How about f of x equals -3x squared minus, how about 15x? Okay, and that's it. That's all it's going to be. So I'm not setting this equal to 0, so don't be going crazy on me. I know everyone wants to factor. Let's factor, but we don't need to do that. So again, I'm going to take a -3 out. If I take a -3 out just of my x terms, I get plus 5x. So if I happen to have like a plus 11 or something here, I would put my plus 11 out here, but I don't have that. So, oh my goodness, I don't know what they're doing outside of my hotel there. All right, let's do this. So I'm sorry, that is very loud. Oh, we're also right by the airport, so you might hear like planes coming through. Half of 5 is 5 halves. You need to make these fractions. I don't want decimals. You should be able to square 5 halves. You are in college algebra. Squaring 5 halves. Square the numerator, square the denominator. We get 25/4. Okay, now here, this is going to be a little bit tricky, okay? What did we actually bring in though? This 25/4 is being multiplied by -3. So I'm going to do a little bit of side work up here. -3, that's -3 over 1 times 25/4. So what did I actually bring in? A -75/4, right? Remember, this guy is being multiplied by that -3 right there. So I brought in a -75/4 because of this minus sign. So what's the opposite of a -75/4? The opposite of that is a positive 75/4. So what do we get finally? -3. I'll be right. I'm going to factor this, right? I need to look at what did I square basically to get that 25/4. Well, what did I square? I squared 5 halves, right? So I would have x, and then it's plus, it takes on the same sign as the middle. 5 halves, quantity squared, plus 75/4. Don't freak out about fractions. I get that they're confusing. I understand that. Like, I understand why you don't like fractions. I get that. They're harder to work with, right, than integers or whole numbers. But that doesn't mean that you can't do it. You can do it. You just got to take your time. Sometimes the fractions aren't going to be like, when I ask you to multiply 3 times 4, you can do that in your head right away. But you can do it just by taking your time, thinking about what's going on, writing down the steps of the problem, and figuring out what that fraction is. You don't have to run to your calculator every time you see a fraction. You really don't. If you practice it now, easy for me to say, I get that. Like, I've been doing math a long time. But the more that you work with them and kind of get used to it, the better it's going to be. It's like working out, right? I don't like to work out when I first start doing it after I've been away from it for a long time. But the more I do it, the better it gets. I can see how I am getting better at doing those things. Okay, I don't know why I just went off on a little bit of a spiel there about that. All right, so what are we doing? I know I'm going over 5 halves, and I'm going down 75/4, which is like way down here, because 80/4 would be 20. So no, why am I going down? I'm gonna go up, right? And up here to 75/4. And then notice, because this is negative, this guy right here is going to open down, right? And it's going to be stretched. Again, I don't have to have it perfectly. I just wanted to get a little sketch of it, because if I sketch it, then I can see, oh, okay, I have a maximum. So I don't have to always memorize things. What is my maximum? My maximum is my y value. So maximum of 75/4. Where does it occur? It occurs at, and then that helps me see what my x value is too, -5 halves. My vertex, right, is that -5 halves, 75/4. And then I have the axis of symmetry is x equals -5/2. Okay. I hope that kind of makes sense. What I'd like to do now is a couple of examples really quick of application. 2 application examples. I know this is getting long, but this is a really, really important section. 2 application examples, and then I'm gonna let you go. So I'm gonna pause this really quick. I'm gonna write down the problem so you'll see it just magically appear so I don't take up your time. So here is our example. You might have to pause the video here so you can write this down, but go ahead and pause it, write it down, and then come back. So the height of a ball, welcome back. The height of a ball in feet thrown directly upward is given by this function. Sorry about that, I got a little too zealous there. -16t squared plus 20t plus 6, where t is time in seconds. Determine the time at which the ball reaches its maximum height. So this is actually a valid equation for finding the height of something. This, if you've had any physics, you may have seen this before, that we can model throwing a ball up, the height of the ball versus time. If you throw it up into the air and let it come down, then it pulls, obviously the gravity of the earth, right? It pulls the ball back to us, and it can be modeled with a parabola similar to this. This number right here is due to acceleration due to gravity, which is 32 feet per second squared. Anyway, there's a reason that's 16, and it's pretty great. Okay. Anyway, so I want to find the maximum. Determine, so remember, what does this function give us? You put in the time, it spits out the height. So I put in 2 seconds, that's 2 seconds after it's been thrown. This will spit out how high the ball is. Notice if you let t be 0, meaning I haven't thrown the ball yet, we have 6 feet. So that would be like a person, apparently a 6 foot tall person is throwing a ball right at like the top of that person's head or something. I don't know. Anyway, that kind of makes sense. Well, maybe not so much for me, but okay. So I want to find the maximum of this. I know this is a parabola opening down because this coefficient right here is negative. So that's pretty cool. So I'm going to take out a -16, right? T squared plus, now I'm not going to be scared of fractions. I'm going to do a little bit of work over here. And I'm not scared of fractions also. I am a little bit scared of fractions that aren't in simplest form because I know I'm going to be doing stuff with these numbers. So if I take a 16 out, right? When I say take out, that means divide by. So I'm going to take 20 and I'm going to divide it by -16, and this is going to simplify to a -5/4. Divide each term by 4. So, so I don't know why I have, let me erase this really quick. Plus sign. Okay. So I will have minus, because the positive divided by a negative is a negative, and I would have -5/4 t, and then I'm going to give myself some space and do 6 right here. Again, don't be scared of fractions. You can do these. Do what you know how to do and just take your time doing it. Don't freak out. I mean, if you want to freak out, you can, but freak out and then pull yourself together and try it. So here I'm going to take half of that middle term, the -5/4. Again, fractions I just multiply straight across, so -5/8, and I'm going to square this sucker. So plus 25/8. Okay? Okay, this is going to be a little freaky. It'll be all right, I promise. It will be okay. What did I actually bring in though, right? I didn't bring in 25/8. I brought in 25/8 times this number out here, which is a -16. I'm going to put that as 16/1. Okay. Again, I brought in 25/8 times a -16. I'm going to, oh, go away. not you guys. Not you guys. I meant that little thing on this. I love the surface, but sometimes I don't always understand it. And now I'm going to take the 18 into the 6, or the 8 into the 16, and I get 2. This is pretty cool. And I get a -50. So I brought in a -50. I brought in a -50. So to counterbalance that, I need to bring in a +50. So that if I multiplied all of this crap out, right, all of that crap out, then I know, I'm trying to write at this and talk at the same time, which doesn't always work. Then I know that it will simplify to my original function. Okay, if I simplify this all out, I know I've done it correctly. Take that time on your test. Take that time on your test to check yourself. You should have plenty of time on your test. And because I'm talking too much, not focusing. All right, so now what I need to do is I need to factor this guy right here into a perfect square that I know it is a perfect square because I forced it to be. What is this term that I squared? It's a negative 5/8. Okay, squared, and then I have 56 plus 56. So look at what this is. This is a parabola, right? That is to the right 5/8, up 56, opening down. So this is the max. This is when it reaches its max height at 58. What is the max height? 56. Okay, sorry. It reaches its max height at 5/8 seconds. And what is the maximum height that it reaches? It's 56. So let's go back and see what this question asked us for. Determine the time at which the ball reaches its maximum height. So I write a sentence. The ball reaches its max height, which is 56 feet, at 5/8 of a second. Okay, or 5/8 seconds would be fine too. Whew, that was a good time. All right, you guys, we have one more to do. One more. You know, if you need to pause the video, go get a stiff drink. Kidding, most of you are underage, so please don't do that. Go get a coffee or soda or something like that, okay? All right, let's do one more. I want to do one more. Whoa, as I drop my pen. I want to do one more of these word problems because I know these can be confusing. You need to email me if you have questions on this stuff. Again, we're not spending a lot of time in class on this, so if you're very confused by this, I need you to set up an appointment with me, come to my office hours, something, okay? You know, that's something that you should do. You should never just, if you need extra help, you should take that initiative. Come and see me, come get help from me. I will be here to help you. I am here to help you. All right, one more. The sum of the base and the height of a triangle is 16 inches. Find the dimensions that maximize the area. All right, find the dimensions that will maximize area. Well, so here's what we got. I have a triangle. I can draw a triangle. Apparently it's an equilateral triangle. It doesn't have to be. And I know I'm gonna label some stuff here. I don't know. Let's get crazy and label the base B, and let's label the height H. Okay, so there are a couple things that we know right here. We know, I'm gonna just take this line by line. The sum of the base and height of a triangle is 16 inches. Sum is addition. So the sum of the base and the height is, in math, is equals 16 inches. Okay, so I know B plus H is 16. This is something, what I like to see is I like to see you label what we know. We know that we're given the base plus height is 16. What do we want? Half of understanding these word problems is just being able to organize the information that they give you and know what you want to find. Knowing what you want to find is like half the battle in life, in mathematics, in so many things, knowing what you want to find. What do we want? We want the maximum area. So we want the max of our area, which is A. A is, what's the area of a triangle? Come on, you know this. 1/2 the base times the height, right? Because remember, triangle is just basically like half of a square if you think about it. So, good. We have 1/2 the base times the height. So this is the equation. I want the maximum of this equation. So this is the equation. This area equation right here is the equation that I need to find the maximum of. which means I need to figure out how to make it a quadratic somehow, because that's what this whole section is about. So how do I make that a quadratic? I have to have some equation that relates b and h, which I have right here. I'm just going to solve for h. It does not matter which one you solve for. This would be 16 minus b. Doesn't matter which one you solve for. And then what am I going to do with that? I'm going to plug it in here so that I get an area equation. I want to have an area equation. That 16 is tough with the b's. You know what I'm going to do, people? I'm going to go ahead and solve for b, so that I'm writing h's instead of b's, because that 16 and b look way too close to my eyes. So it doesn't matter. It doesn't matter which one you solve for. I'm going to solve for b. That'll be h. So I have 1/2 h times 16 minus h. Okay? So again, all I did, so I actually plugged that in here. All I did was solve for one of the, we've done this before, we saw this in 9.1. I'm going to solve for one of the variables and plug it into the function that I want to find the maximum of. Plug it into the function that I want to find the maximum of. I'm going to take that negative, or I'm going to take the 1/2 h through. Oh, look at that. That is so weird. Why is that so weird? Because we got a quadratic. Well, who would have thunk it? All right, so I have a negative 1/2 h squared plus 8h, and I'm ready to go. This is good. This is good news, right? I don't know if you think it's good news, but it's good news. A couple of things. I got a quadratic. That's good news, because I know I want a quadratic. The other good news is that this negative right here tells me it's a quadratic opening down, which in turn tells me that I have a maximum. So that's good news. All right, I'm going to take, oh my goodness, go away. Again, not you. All right. So I'm going to take negative 1/2 out. Okay, again, don't freak out here. Don't freak out. Don't freak out. I'm going to take out a negative 1/2. So I'm going to take h and divide it by a negative 1/2. Look at what that says. That says how many halves are in 8, or flip the 1/2 and multiply. So I get a negative 16. You guys, on here, you should always, really quick, especially when you're like factoring out fractions, really quick, distribute that negative 1/2 in your mind, or do it on a piece of paper or something, and make sure you did it correctly. If I take negative 1/2 times negative 16, I get a positive 8. Negative 1/2 times negative 16 is a positive 8. I did it right. Okay. Now I'm going to take half of 16, right, which is 8, I believe. Yeah, because we just did that. Half of a negative 16, which is a negative 8. I'm going to square that sucker. And I'm going to add this in to complete the square. Then I'm going to look and see, what did I actually bring in? What did I actually bring in, people? I brought in 64 times negative 1/2. So again, little bit of side work isn't a big deal. Negative half of 64 is a negative 32. Okay, negative 32. So what did I actually bring in? A negative 32. So the opposite of a negative 32 is a positive 32. Awesome. So what do we have? We have a negative 1/2 times. I'm going to go ahead and complete the square here. So I have h minus 8. Again, you must use the completing the square method. I am going to force you to. Do not memorize the b over 2a. I mean, you can memorize it. I can like tell you what to memorize and not memorize. But if you don't show me the completing the square, you won't get credit for it. Look at what this is. This is good. This is a parabola opening down. It's been shifted to the right 8, right? It's been shifted up 32, and it's been kind of compressed. Oh, that's not perfect, but it doesn't have to be. Find the dimensions that will maximize area. So this 32 right here is the maximum area. When does that maximum area occur? It occurs when x, or h, is equal to 8. So h is equal to 8, and then I come up here and I think about putting that 8 in here, and if I subtract, I get 8 for b. So I would write a pretty little sentence, but I'm not going to do that for you because we're about done. When my height is 8 feet and my base is 8 feet, then I know that I have maximized the area of that triangle with the restrictions, right, that the sum and the base add up to be 16. Whew, we're almost at 40 minutes. Hope you guys hung out with me for that whole time. Do the fun sheet. Look up the solutions for the fun sheet. They're on Blackboard. Do the homework and come to class on Tuesday ready with questions. We can go over some questions, of course, but we're not spending a lot of time on this. We're going to start new stuff on Tuesday. All right, you guys, I miss you. I hope you have a wonderful weekend. And will you please send me a quick email if you have any questions.